Goodreads Self-Growth: A Brief History of Time. Stephen Hawking. This book is written by Stephen Hawking. It is a FEM book of science. Hawking has told about universe. This book explains the story of the start of time, space, black holes, and universe. It has also been explained how physics works. Theory of relativity and quantum mechanics is also explained. Hawking has tried to write the science in a simple manner in this book so that the common people can also understand. This book opens the secrets of the universe and raises new questions. Let's try to understand this book. Chapter 1: Our Picture of the Universe. A photo of our universe. A famous scientist. Some say he was Bertrand Russell. He once gave a lecture on astronomy. He told that the Earth dreads the sun and the sun revolves in the middle of a large galaxy. After the lecture, an old woman got up and the bid you told is all wrong. The world is like a large plate that is laid on the back of a large giant turtle. The scientist laughed and he asked what this turtle stands on. The old woman bids you are too sharp, but just below and just turtles. Most people will make a joke on how we believe it is right about universe. What we know about how it came from and where there was no beginning of the universe. What was before it? What is time? One day time will stop whether we can go back to the past. New scientific discoveries are beginning to answer these questions. Today, as we believe that the Earth is dizzy of the sun, from a day, the new facts will make us look obvious, or perhaps the same will look as strange as the Tower of the Turtle. Greek philosopher Aristotle in 340 BC wrote a book on the heavens. He told that the Earth is round, not flat. He had two large proof. When the lunar eclipses occur, the Earth falls between the sun and the moon, which falls on the shadow. Moon is always round. If the Earth is flat, the shadows sometimes look like an elliptical, i.e. a long round. And the second, when the Greeks traveled to the south, the North Star, i.e. the pole star, appeared down from the North Pole. It appears upright, but from the waiter he is near horizon. The Aristotle from these defenses embed the Earth's size 4 lakhs stadia, which was the double of today's accurate figure. There was also a third proof, when a ship came from afar, before his sails appeared, and then gradually the entire ship appeared. Aristotle assumed that the Earth has stopped, and the sun, moon, and the planet make its dizziness. Talani further paved this model in the 2nd century SV. His model is in the Earth's center. He has 8 round shells in which the moon, sun, stars, and Mercury, Venus, Mars, Jupiter, Saturn are all walking. Stars are connected in a fixed sphere that rotates. This model was accurate on a problem. This model believed that the moon sometimes falls to the Earth and which never appears away. Yet the Christian Church considered this model as a divine, as it had space for have and hail. In 1504, Nicholas Copernicus gave the new model. It was in the sun's center and the planet was dizziness of it. This model was an ominously circular as the Church could assume it heresy. Galileo in 1609 saw from the telescope that the little moons around the Jupiter are walking. This means that everything was not dizzying the Earth. Johannes Kepler modifies the circular orbit of Copernicus and pointed out that the planet ellipse, i.e. long rounds, rotate in the orbit. It began to be matched with theory-accurate observations. In 1687, Isaac Newton took the Principia Mathematica published, which is considered the most important book of science. The Newton gave the roles of motion and time-space. The universal gravity law gave that every object untreats the second object as it would be bigger and the more it would pass. This was the same force that dropped the object to the Earth. That's probably just a story that came to Newton's idea from the famous story that falls an apple. Newton showed that gravity is the reason why the moons dizzy the Earth and the planet live in the sun's orbit. After the model of Copernicus, the idea of the celestial ciphers was over. Now it began to assume that stars are also like sun but far away. On Newton, a big problem appeared. If the universe is infinite and all the stars are stuck to each other, why the universe does not fall to a point? In 1691, Newton wrote a letter stating that if the stars are finite, then fall to each other, but if there are infinites, then do not fall, as there is no central point. This infinite was an exam of universe's problems. Now we know that the stable infinite universe is not a possible. If the gravity is being stuck, will have to either expand or have a contact. The first people of the 20th century believed that the universe was always the same or God made once. Newton's gravity's law was showing that the universe could not be static. Instead of considering that, people tried to modify the gravity so that a balance remained. He considered a lot of repulsive to gravity so that stars stayed in a balance. But now we know that if this model is unstable, the universe is unstable. If some stars come to each other, then they come to pass and go away if they go away. By the 20th century, there was no thought that the universe could be expanded or contract. All seemed that the universe is always the same. But now we know that the discovery of the University of Einstein's relativity theory and Edwin Hubble found that the galaxy is going away from each other. If this is true, it means that the universe was in a short place at a time. This means that there was a beginning of the universe that today we know as Big Bang Theory. Another big objection of an infinite and static universe German philosopher Heinrich Albers gave in 1823. It was also thinking about the scientist of Newton's time, but the argument of Albers was the most famous. The problem was that if the universe is infinite and static, there should be no star in every direction. The whole sky of the night should look as bright as the sun. Albers responded to that the dust and gas falling between the light of the far stars tends to be absorbed. But if this happens, the matter also gradually heated and the brighter the stars. The project was just a single solution: either stars will be started on a fine time or yet their light will not reach us. It raises a big question: when it began stars. The question of the beginning of the universe began on a finite time in the old civilizations and Jewish, Christian, Muslim trades. There was an argument that everything happens because of the first side of the universe. Christian thinker St. Augustine wrote in his book The City of God that human civilization is progressing if we can remember civilization's invention or important people. This means that human civilization cannot be too old. St. Augustine considered the creation of universe at the basis of Genesis in 5000 BC. This is esteemed surprising as civilization began in about 10,000 BC even according to the archaeologist. Greek philosophers like Aristotle did not like the creation theory as it seemed to be a divine intervention. He believed that human race and universe were always and will always remain. He responded to the argument with the progress of St. Augustine that bars lead to large catastrophe, i.e., floods or disaster civilization initially. Philosopher Immanuel Kant in 1781 deep discussions on the beginning of the universe in the Critique of Pure Reason. He said it to be an antinomy means such contacts that have a strong logic on both sides. One side argument was that an infinite time occurs before any event that the universe does not start. On the other hand, there was an infinite time if the universe started on a finite time. Then why the universe started on a perpetual time? The base of both argument was the same. It believes that time can go back to the infinity. On the St. Augustine had earlier reported that the time's piling is only when the universe Angus performs. When asked him what God did before making universe, his answer was time itself, a thing that God made with universe. There was no sense of the first time of the universe. The first people believed that the universe has always been the being. The question of his beginning was just as the topic of philosophy or theology. Whether you could say the universe is always or could even say that God started the universe on a finite time in such a way that he looked old. On 1929, Edwin Hubble has a big discovery's galaxy is going away from us. This means being a universe expanded means it was earlier in the time it comes to if the reverse was the same place and it was a density infinite. It made the base of Big Bang theory. The first time the question of the beginning of the universe became the topic of the science. The discovery of the Hubble adorned that the universe infinite was short and infinite dense at a time. All physical law fails in such conditions. If there are any events before Big Bang, they have no effect on today's universe. Meaning time's definition is not only before Big Bang. This means that time starts with Big Bang. The first people took the idea of static universes because they believed that a creator of universes would have come from the original external force. But if the universe is being expanded, there is probably a physical reason that its beginning is necessary. One can also say that God started the universe after Big Bang's done with him of Big Bang, but it's only meaningless to imitate the first universe of Big Bang. Expanding universes idea doesn't make a creator inseparable, but it definitely tells that if there was a creator, he started his work on a positive time. If we have to understand the nature of the universe and know whether it was started or not earlier, it is important to understand what is the scientific theory. A theory is a model that expels a part of the universe. If he/she can match with observation and give a new production, he/she is good. As Aristotle believed that four elements, i.e. the meaning makes everything from air, fire, water, but it didn't give any predisposition. Newton's gravity's law was also simple and also practicing high accuracy. There is no theory final proof in science. Any theory surveys until an experiment misleads him. Just as Newton's gravity law was practicing the motion of Mercury a little wrong, Einstein's relativity theory performed it. Newton's laws still work in the daily use cases as it is simple with Einstein's relativity and is also inaccurate on small scales. Science's ultimate goal is to create a single theory that dissipates the entire universe. Scientists see two things different from the law to tell how the universe is changing and how the essential state of the universe was. If a final theory meets the time, space, gravity, quantum mechanics, and the originals of the universe together, it will be the greatest discovery of science. Some believe that science just focuses on universe's roles, but the question of its beginning is the matter of releases or metaphysics. He says God is omnipotent, he could start the universe in any way. If this happens, the development of the universe could also be complete random, but it's not that the universe has been in a spatial manner, the awarding of the fixed rules. If the law is applied on the evolution of the universe, it is logical to believe that there will be no roles on its initial state. It's quite difficult to make a whole universe disabling theory, so we make different mutual theory. Every single theory just explores the limited observation or ignoring the rest of the factors or retrieving them in just the simple numbers. This approach may be wrong if every element of the universe has a deep depend on each other. It is impossible to reach a full solution by different studies to separate parts. But so far we've done this way. The Newtonian gravity theory is the best example. Newton pointed out that the gravity between the two objects just dips on their mass. This means that we can call their motion if we don't just need to understand the structure of the sun and the planet. Today we dissipate the universe from two major mutual theory. First, general theory of relativity, and second, quantum mechanics. General theory of relativity. This exploits the large-scale structure of gravity in universe. This theory covers a scale cover from mile to 10 trillion miles, i.e. 1 to 24 gyro. Quantum mechanics explains the phenomena of this very small scale that is as much as a million part of an inch million. It's a big probable on both. The theory doesn't match each other. The relativity disassembles the gravity. Quantum mechanics works at the microscopic level, but both do not work together. Both may not be right. Today, there is one of the biggest findings in physics. One such theory of quantum theory of gravity that combined both relativity and quantum mechanics. Now we don't have this theory, and maybe it's time to meet it. We already have some of the essential properties of this theory. In the coming chapters we will see how some of the predications of the quantum gravity theory we have to know already. If you believe that the universe runs from the fixed law, they ultimately should get a final theory by combining all the relevant theory that disassemble the entire universe. Here is a big paradox. We believe we are the rational beings that can freely observe universe and take logical deceit. If a completing unified theory exists, he will also detach our accreditations, meaning that the theory will dissipate whether we will reach the right component or not. Then a big question arises if the theory may force us to misconduct or we will not be able to access any concussion. An answer to this paradox Darwin gave to the natural selection principle. The organism that can accurately understand the world around you and react accordingly is cervical. That organism removes the wrong convulsions. To date, the intelligence and scientific discovery has helped in survival, but in today's time it is not clear whether science will always help our survival. Our discoveries can also eliminate us, and if we find a complex theory, it is probably not possible to put any effect on our survey. Science-ality has given considerable accurate theory that can be expelling everything except for the most extreme conditions. This means that the practical life doesn't get an ultimate theory. But if we apply to the same logic past, quantum mechanics and relativity theory never comes, and it's a breakthrough like nuclear energy and microelectronics. A final theory probably don't help our survey, but we'll still continue to afford for him as people didn't want to watch the event random from the beginning of civilization. The biggest goal of our curiosity is a complex decryption of universe. We are the oldest and deepest question of how we came from here, and we will continue to discover as long as we do not respond to them. Chapter to space and time. Today we have come from Galileo and Newton's deposits that know the roles of motion. Before these, people considered Aristotle. Aristotle said that any object occurs in the rest in its natural state and moves just when there was any force on it. This means that heavy objects drop sharply from the light object as their bridge will be higher. Aristotle and his followers believed that thinking can be understood by the universe's law, not needing experiments. So no one tried to check whether objects with different weights really fall from different speeds or not. They thought it as pure. Then Galileo tested the idea of Aristotle. The story that Galileo dropped the object from Pisa's lean tower is not true. Galileo rolled the balls of different weights on the smooth slope. This shows the effect of the beam gravity, but gradually in speeds, making it easier to take the mermaids. The result came that the weight of objects does not affect their acceleration. If a slope goes down 1 m every 10 m, a ball will increase the second and the same speed at 2 m after 2 seconds with a speed of 1 m after a second, whether the ball is light or heavy. A feather and a heavy weight fall apart in the air as the air resistance is different, but if there is no air resistance, both will fall together. Astronaut David R. Scott in Apollo 15 mission tested this on the moon. There is no air on the moon. The feather, i.e. feather and heavy weight, both fell together. Newton used to create the law of motion by Galileo's experiences. Galileo showed that as long as the object rolls on a slope, the force, i.e. gravity, excretes it every second. Newton acknowledged that the force's unitary work is to change the speed of an object and not just move it. Newton wrote Principia Mathematica in 1687, in which he gave the law of motion and gravity. Newton's first law was that if there was no force on a body, he will always move from constant speed in a straight line. Newton's second law was that when a force seems to be on a body, he acclimates in to be a proposal of the acclimation force and the lower acclimation as much as the more force of the mass production. The engine of a car will be as powerful as soon as it will increase the speed, but if the car is too heavy then the acceleration will be lower. Newton pointed out that every object untreats another object and is the proposal of force mass. The gravity force will also double if the mass of an object is doubled. If the mass of an object is 2 times and 3 times of another, the force will be 6 times. This is the rise that all bodies fall from the same speed. On a heavy body, the double force will take place on it. The force and mass will be cancelled in accordance with the second law of Newton, and the acceleration will remain the beams. Newton's law also suggests that as much as the distance will be as low as gravity. If the gravitational force of a star is 4 times, then it will be 1/4 when the distance square grows. If the gravidity is different, the planet is not able to walk in the elite orbit. Either it falls into the sun or exits, and there is no such preferred rest state. Aristotle believed that the Earth is in the rest and everything else is walking. Newton pointed out that there is no point of absolute rest. If a train is going through the speed of a war on the 90-mile, then we can say that the train is moving and the Earth is in the rest, or moving the Earth and is in the train rest. If there is a ping-pong ball playing in the train, then the ball will move the beanway like moving on the table on the track. Meaning motion relative is not absolute. Any event may not have an album position if there's a motion album. As a ball inside the train will appear falling down straight, the ball for a man standing on the track will look falling down while creating an arch as the train is moving. The position of any event may be different for the default observers. Newton was harassed as it didn't match the concept with his absolute God, but the philologues praised this idea. Newton and Aristotle believed that time absolute would have any object time to majorize some result. Time and space are different. It seemed to be common sense, but it is wrong. The Danish astronomer Ole Romer in 1676 showed that the light travels from a finite speed. The eclipse of the moons of the Jupiter is not always in the beam gap when the distance between the Earth and the Jupiter grows light line. Romer gave a second at the estimate 140,000 miles of light, which was close to seconds on the modern value, i.e. 186,000 miles. James Clerk Maxwell in 1865 revealed that light is a wave that travels from a fixed speed. If the wavelength is large, then the radio waves are formed. If the wavelength is small, the microwaves, infrared visible light, ultraviolet, X and gamma rays are formed. Newton's physics practices the motion of cars and planets on the point when the speed is close to the light. The Newtonian physics fails. That's why Einstein's relativity theory begins. Maxwell's theory prompted that radio and light waves travel with a fixed speed, but Newton had removed the concept of absolute rest. If the speed of the light is fixed, it came to the question of which the speed will be relative. An imagery substitution of the ether name was proposed to solve this problem. As sound waves travel in the air, the light waves travel in the ether. If the ether is ageist, the speed of light should be different for those who are moving relatives of the observer's ether. When the Earth is going to the ether in its orbit, the speed of light should be higher and the speed of light should be lower when the Earth moves its perpendicular. Albert Michelson and Edward Molly in 1887 made a good careful experience in Case School of Applied Science, Cleveland. He programmed the speed of light in the direction of Earth motion and in the perpendicular direction. Result turned out to be the speed of light in both the diagrams. The result was unexposed, as the speed should be different if there is a ether. George Fitzgerald and Hendrik Lorentz rested that perhaps the object gets contracted while moving to the ether and the clock slows down, but it seemed to be an explanation artificial. Albert Einstein in 1905, who was clerk at that time of Swiss Patent Office, and published a paper, he said that ether doesn't need it, just we have to leave absolute times idea. Henry Poincaré also took the same point on Einstein's approach. Physics was based on the credit of theory of relativity. Einstein's relativity theory is a simple principle based on science's law should be obedience for all freely moving observers whether their speed is anything. In the law of Newton's motion, it was already true. Einstein also put the speed of Maxwell's law and light into this rule. All the observers should always see the speed of light whether they are moving themselves with a speed. Einstein's relativity theory had two major conceivities. The first, energy and mass relations, i.e. E equals mc2, and the concept finish of the absolute time. Einstein showed that mass and energy are linked to each other. E equals mc2. The speed rises as much as energy increases and the more mass increases. If an object moves from 10% of the speed of the light, then his mass will increase just 0.5%. If it moves by 90% speed, the mass will double from normal. If an object began to reach the speed of the light, his mass will be infinite. Light or waves that are massless can run by light speed. the second album of time he finished. The time in Newton's physics was an absolute quantity that meant a being for everyone. If an observer sees a light pulse from one place to another, then all the observers will aggregate how much time he took. All the observers will not aggregate how far he went away. The relativity is reversed. All the observers will aggregate that the light has a speed being, but they will not aggregate how far the light went. Time will also be different major if distance is different major. Every observer will have a different time scale. If two observers move the identical clocks along with themselves, they will not renew. Every observer can send a radar pulse to majorize its time and position. Observer sends pulses that reflect on an event and reacts to the observer reflection. The time of the event is the midpoint when the pulse was sent and the time between the reflected. Multiply the half-time with the speed of the event's position light. This process is shown through space-time diagram in relativity. If two observers are moving relatives from each other, they will do different time and position tables of the same event. No observer's tablement is correct or wrong, but all observers' tablement is connected through an equation. Today we use time to make the distance accurately measure. A meter is defined that the light travels as much as 1/299,792,458 in a second is 1 m. This number was selected because it matches the historical meter definition of the platinum bar laid in Paris. Distance in the relativity theory is defined by the speed of time and light. Due to this, every observer will always get light speed beams. Michelson-Morley experiment showed that ether doesn't age. Does the relativity theory suggest that ether doesn't even need? Newtonian physics had different things in space and time complexes. 3 coordinates are required to tell the position of an object. Time is an independent quantum. At Einstein's relativity theory showed that space and time is not different, but the same thing as space-time. We need 4 coordinates to defend an event, 3 space coordinates and a time coordinate. Any observer can use different coordinates. An observer will program the time and position of an event in a coordinate system while the second observer in the second coordinate system. Einstein showed that time and space is relative and is part of an unified for dynamic structure that we call space-time. So we need 4 coordinate to facilitate an event of 3 space and 1 time. This 4 dynamic space-time defines a specific location. If the light comes out of a place, it will form a 3-dimensional corner in the space-time that will further increase the future. This cone is called a future light cone. Similarly, past events have a corner with events from which light can reach out to one event. This cone is called the past light cone. All events from the universe for an event P can be diverted in 3 categories: future light cone, past light cone, and elsewhere. The future light zone is all events that can reach the speed of the light from the P to the low speed. Past light zones, i.e. events that can uncheck the P as light or signals from the event can reach the P, and the events from which we can uncheck the P and not be able to uncheck the P. When we look at the sun, he makes us look as he was 8 minutes ago. After 8 minutes of an event that occurs on the sun, it is affected by the earth. Future light will come to the corner and feel the effect. Similarly, when we look at a distant galaxy, there are no presentations but millions or billions of years ago. In 1905, Einstein made a special relativity theory practice that ignored the gravitational effects. For every event there is a light corner as the speed of the light is the same place. Due to this, every light corner points into the beam direction. The relativity theory says that nothing can be faster than the speed of the light. If an object moves, then it will always be within the light corner. If the Newtonian gravity is correct, it means that the gravity force instantaneous effect does not match the relativity. Einstein, between 1908 and 1914, tried several times that a gravity theory developed that is compatible with relativity. In 1915, finally Einstein made a revolutionary theory proposal called general theory of relativity. Einstein said that gravity is not a force but has the effect of the curvature of space-time. Newton assumed that objects impose each other from force. Einstein said that the objects move in a curvy space-time in which he followed the natural geodesic. The Earth does not imply the sun's dizziness from any force, but he follows a natural geodesic in the curved space-time. Just as a plane fly on the round Earth, she will follow the shortest path, i.e. the great circle. Just follow the curved path in the planet space-time. Newton's gravity theory planets elliptical orbit predicated accurately on the orbit of Mercury takes a little different. Einstein's general relativity inducted that the orbit of the decree will process slowly, i.e. a rotating of the axis of ellipse. At the Newtonian physics, it was not being expelled, but Einstein's theory gave the current prediction. Later, the small dividend of the rest of the planet was also checked with the radar measurement and matched with the general relativity. There was another major predisposition of general relativity that the gravity light will bend the path. If the light of a star came from the sun, it will bend a little and we will see the position shift of the star. It is impossible to see in the normal day as the light stars of the sun do not see. On 1919, a British expedition unveiled the solar eclipse and gave proof that the light walkie bends. It was a great movement to prove Germany's theory by the British scientists who made a grinding symbol after World War. General relativity predicts that gravity has time slows. The more gravity will last. If a light beam moves up to gravity, it will lure energy and reduce its frequency. Accurate clocks was placed at the top and bottom of a tall water tower in an experiment in 1962. The bottom clocks that was in the much gravity was running. It matched with the advances of the executive general relativity. Today, GPS satellites also condense this effect or can be inaccurate in the calculation kilometers of positions. Newtonian physics had time absolute, but time is also relative in relativity. Let's say that a twin stays on the mountain, and at the second sea level, the mountain twin will be a little more aged as his time will be faster. If a twin spaceship roved close to the speed of the light, then his brother will be much older than him. This is the twins paradox, which only seems to be paradox if an absolute time is considered true. The time of every human being can be different according to the relativity that depends his motion and position. Space and time before 1915 were considered a fixed stage with events. The effect of the forces in the Newtonian physics was just on objects, but the space and time remained unaffected. Space and time were also a fixed background in special relevance. On general relativity showed that space and time are also dynamic. He also has effects from events in the universe. When a body moves or acting on a force, the character of space-time changes. Space and time is not just a background, but also the motion of the actively universe. After general relativity, the idea of static universe was over. The universe turned out to be a dynamic entity that will either expand or contract. The old idea that said that universe was always the same as was wrong. In the next chapters, we will see how this discovery took a resolution and how Big Bang Theory remains. The work of Roger Penrose and Stephen Hawking was based on the concept of the same new space-time in which he proved that there could be a definite bounding of the universe and perhaps a definite end. Chapter 3: The expanding universe. As the sky is seen at a clean and dark night, the brightest objects that appear are planets such as Venus, Mars, Jupiter, and Saturn. There are also thousands of stars in the sky that are just like our sun. Many people believe to fix the stars, but in reality he moves a little bit. We see these stars from different positions when the Earth is dizzy of the sun. This movement is very low just for the stars that are close to us. Nearest star Proxima Centauri is 4 light-years away from us, meaning his light takes 4 years to reach us. It equals 23 trillion miles. Stars that appear from the eyes are within a few hundred light-years. Our sun is just 8 light-minutes away. Stars that appear in the sky on the night look scattered everywhere. A place on the scattered is very constructed. This band is called Milky Way to this area. In 1750 some astronomers adorned that Milky Way could be like a disk. Then Sir William Herschel catalogued the position and distance of a lot of stars to make the confirm that we are in a spiral galaxy. By 1924 people believed that it is the whole universe. On Edwin Hubble proof that there are even more galaxies. Edwin Hubble showed that there are thousands and galaxies even in addition to our galaxy, but they had to remove the distance of these galaxies to prove it. The distance of the nearby stars is so we can do the direct measure, but the galaxy is very far. Because of this, the Hubble used the indirect methods. The brightness of a star dips on two things, that is, luminosity and its distance. If we find a star with a known brightness, head the distance to it, it will also be a real luminosity and remove the galaxy's distance on the bases. If the separate stars of the same galaxy come out of the distance, we can be sure that we have done the right tabler. Similarly, Hubble had success in removing the distance of 9 galaxies. Today we know that our galaxy is just one of the 100 billion galaxies we can see from the modern telescope. Every galaxy also has up to 100 billion stars. We live in a spiral galaxy that is 1 lakh light-years wide and rotates slowly. The stars of the galaxy once put several hundred million years in the dizziness of the center. Our sun is an average yellow star that is near the inner edge of the spiral arms. We understand how we have come away. First, people think that the Earth is the center of the universe. Stars are far away, so they just look a glossy point. We can't know their shape or size. The biggest way to recognize a star is the color of his light. Newton had shown that if the light passes through a prism, it is diverted in different colors. Similarly, if we look for a star light from a telescope, we can see its spectrum. The spectrum of the default stars is different. The spectrum of a star tells its temperature. Every glowing object emits a spatial thermal spectrum. Some of the spatial color spectrums contain absent Every chemical element absorbs a unique set of colors. We can tell its elements if it looks missing colors in the spectrum of a star. In 1920, when the spectrum of the stars of the second galaxy was seen, they found a strange thing that their spectrum was shifted to the red side. It is caused by Doppler effects. When an object comes to us, the wavelength of his light is shortened, i.e. blue shift. When an object goes away from us, the wavelength of his light becomes large, i.e. the red shift. Take the sound of a car. When the car passes, his sound is heard in the high pitch and goes away in the low pitch. Similarly, the light also shifts with the source that moves. The Hubble cataloged galaxies' distance and their red shift. If the galaxy random moves, then some blue shifts and some of the red shifts were supposed to be. The almost galaxy red shift appears mean he was going away from us. In 1929, Hubble has another great thing to do as far as the galaxy of the publish is going away from us. This means that the universe is not static, is spreading, expands. The physicists of Newton and then had to understand that if the universe is static, the gravity will make it collapse. If a universe is slowly exaggerated, the gravity can pull it back and wrap it back. If the expand is too fast, the gravity will never stop it and he will always continue to expand. This is the same concept that is applied at the speed of a rocket. If the speed of a rocket is low, the gravity will pull it back. If he is faster than a second on 7 miles, he will escape and will not come back. When it could be a predict from Newton's physics, people believed that no one thought. Einstein considered static universe true even when creating general relativity. He inserted an artificial cosmological component that works on gravity. This force did not come from an object, but also an agent in the structure of space-time. It was designed to keep the executive universe in balance. But Einstein, after the discovery of Hubble, believed that it was his biggest mistake. Just a man took the relativity serious was the Russian physicist Alexander Fredman. On Einstein and the second physicists were looking for a solution for a static universe, Fredman tried to understand the expanding universe. Alexander Fredman put two simple ideas about the structure of the universe. The first universe looks the same in every direction and the second one will see if it comes from another place. Fredman, on the basis of just two of these two genres, showed that the universe cannot be static, means either he will expand or contract. Fredman gave this conclusion in 1922, several years ago of the discovery of the Hubble. In 1929, the Friedman, who was exposed in 1929, had already done his prediction. At the practical level, the universe does not look the same everywhere. Milky Way appears as a separate band. The galaxy cluster consists in not a single spread everywhere. When we look at the large scale, the galaxy seems to be the only distributed in every direction. The first people used to consider Fredman's idea as a rough approximation. The latter was proved that this idea is right from the remarkable accuracy. Arno Penzias and Robert Wilson in Bell Telephone Laboratories, New Jersey in 1965 were testing a sensitive microwave detector. He was getting an unwanted noise in the detector. He checked all wrong, source, instrument fault, atmospheric bird droppings, also everything. Noise was a bean in every direction and was a permanent day, overnight. This means that the noise was not just coming from the solar system but from the entire universe. Later it turned out to be the cosmic microwave background, i.e. CMB radiation, which was a left nature's signature of Big Bang. At the same time, Bob Dick and Jim Pebbles were also interested in microwaves at Princeton University. He studied George Gamiot's idea, who was a Friedman student. Gamiot said that early universe was very hot and dense, that white hot glowed. If it was a glaze gaseous, then today it will look in the form of highly red-shifted microwave radiation. When Dick and Pebbles were planning to find it, Penzias and Wilson heard their work and understood that they have already been discovered. Penzias and Wilson found the Nobel Prize in 1978, but not the Dick and Pebbles that took a little unfair. If the galaxy in every direction is going away from us, one might think that we are at the center of the universe. But Fredman had a second idea, that every place will see the beams. When there are spots on a balloon, all the spots go away from each other when the balloon floss. Every other smear will look away, but there is no center. The model of Fredman matches the red shift observation of the exact Hubble, but his work remained unknown in the West until Howard Robertson and Arthur Walker did not rediscover the beams model in 1935. The application of Fredman offers models of three possible universes. The first closed universe, i.e. the expand and then the contact will be. If the exemption is slowly, the gravity will pull it back and make it clear. After a time, all the galaxy will come a place. This cyclic model can be a big bang by having a big crunch then another. The second open universe, i.e. will always expand. If the extension is too fast, the gravity will not be able to stop it. The galaxy will always keep away from the universe infinite. And the third critical universe is exactly as fast as the expansion on the balance, that the gravity just is balanced and the expansion will remain slowly but will never stop. We have to monitor the current exchange rate and density of the universe to edit it. We can measure accurately from the velocity Doppler effect of galaxy. We know the universe 5 to 10% is being expanded every billion years. It is difficult to do the exact distance accurately measure of the galaxy on. If we add all the visible galaxies' mass, then it's very low to stop the expulsion. On the galaxy there is dark matter that puts the effect on gravity on the directory does not appear. Even if we also add a dark matter, the total mass is just the 10th part that should stop expulsion. There's no proof yet that there's another hidden matter that can contact the universe. This means that the universe will probably always expand. However, if an extra matter is diagnosed, the future can sometimes have collapse. The Fredman model suggests that the galaxy was a place at a single point. It was a singularity, i.e., Big Bang. There was density and curvature infinite. Mathematics cannot handle the infinite numbers. The relativity units fail here. If there were any events before Big Bang, he cannot put the effect on the future. Meaning is the Big Bang of time for science. Some of the scientists were adding Big Bang to the concept of the divine creation that they didn't expect. In 1948, Harman Bondi, Thomas Gold, and Fred Hoyle made the steady-state theory. He said the universe seems static as the new galaxy continuously formed. A new star system form is in place when a galaxy goes away, meaning universe will always look alike. The observations of this theory were that any part of the universe should have the beam's number of galaxies at any time. The radio survey of Cambridge astronomers Martin Ryle in 1960 has proof that the galaxy was higher in the past. Universe cannot be static if the galaxy was much in the old time. The microwave radiant discovery of Penzias and Wilson was also proof that the universe was a lot of dense in the past. STD state theory was selected in 1965. Big Bang has become a psychotropic fact. Now the question of how universe happened after Big Bang. Another attempt to ascribe Big Bang took place in 1963 by two Russian scientists Yevgeny Lysitsyn and Iz Koletnikov. He said that perhaps the Big Bang is just a limitation of Fredman's models, which is just a rough imprint. The galaxy is not just going straight away in the actual universe, but also there's side wedge motion. Perhaps the universe will never be compressed to a place if it is side wedge motion concealer. Perhaps the universe was in a contacting phase in which the particles came out from each other without having to come a place and are now being expanded. Lysitsyn and Koletnikov created models in which the galaxy moves with random velocities. He showed that in some special cases, the universe could start from a single singularity, but he had to say that such special models would be very rare. Big Bang in most cases does not singularity exist. But in 1970, he took this claim back as it turned out that a lot of models still contain singularities. Lysitsyn and Koletnikov's work could not prove whether or not a Big Bang should be in accordance with the general relativity. It came from a new approach to Roger Penrose in 1965. Penrose showed that when a star culps in his own gravity, he is stuck in a regeneration whose size can be zero, meaning his entire mass becomes an infinite dense point of a singularity. This singularity occurs inside a black hole. First, it's just applied for stars to show not the whole universe. At the same time, Stephen Hawking was looking for a problem for his PhD. Hawking was diagnosed with ALS, motor neuron disease, diagnosed in 1963, and doctors had said that he could be just 2 years and live. For this reason, he didn't pay attention to the first PhD, but when he surveyed, he thought to continue his research. He read the theorem of Roger Penrose and realized that if reverse time he is applied on Big Bang. If the theorem of Penrose reverses a collapsing star, then an expanding universe should also be triggered by singularity. Penrose's theorem was telling that a collapse would be. Hawking showed that an expedition would start from the universe singularity. This is only possible when universe is like a Friedman model on the large scale. The first Penrose's theorem was just applied to the cases in which the universe is infinite. Hawking took the new mathematical techniques development to remove this reaction. He acknowledged that if the general relativity is right and the same matter in the universe is as we can see, there will be a single singularity. In 1970, Hawking and Penrose took a joint paper in which he proved that the universe will surely begin with a single singularity according to general relativity from a Big Bang. This means that a definite of time and space was buzzing. General relativity is an incomplete theory as he cannot tell how a universe started. If all physical theory fails at a point, we can't predict the past. The work of Hawking and Penrose was very opposed to Russia. The communist scientists kept the bile on determinism. Singularity meant that universes are not predictable. That was the age of their ideology. Some of the scientists weren't liked as Einstein's universe was an elegant and smooth theory and singularity was making the theory awkward. But there is no argument of the mathematical theorem. At the end, everyone got it done. To date, the mostly scientists believe that the universe began with a singularity. Hawking did this theorem proof, but today he believes that perhaps singularity was not real. Adding the effects of quantum mechanics can lead to singularity disappearing. Over 50 years, the cosmology of the entire human history changed. The discovery of the Hubble showed that the universe is being expanded. We realized that the research took place as it turned out that there was a definite billioning of universe. In 1970, the finale Hawking and the Penrose proposed that the Big Bang singularity should be born in accordance with the general relativity. On general relativity is an essential theory, it cannot tell what would happen inside singularity. A new theory is needed to go to the point where the physics breaks. If there was a Big Bang singularity, she was in a regeneration where quantum effects dominate. The relativity works on the large scale, quantum mechanics works on the small scale. Both of the effects were important when the universe was too small. At the beginning of 1970, the physicists had to understand that only the relatives will not get dependent. Now the focus shifted to a new round, the quantum theory of gravity. In the next chapters we will see what quantum mechanics is the connection with its gravity, a supplement theory that will be what the universe is spinning and evolution to be launched. Chapter 4, the uncertainty principle. The French psychist Marquis de Laplace gave an idea by observing Newton's gravity theory. If we know the express state of the universe at a time, we can prompt future, meaning a deterministic universe in which everything moves according to a fixed rule. If we know the position and speed of the planet, we can call their motion forever from Newton's law. Laplace had said that this rule is not just limited to the planet, but is applied on everything including human behavior. This scientific determinism did not like many people as there was no place for God's intervention on the belief moving until the quantum physics broke it in the starting of the 20th century. The first challenge of determinism of Newtonian physics came to the end of the 19th century. Lord Rayleigh and Sir James Jeans showed that if a hot object radiate heat, every frequency should have equivalent energy radiate. The problem was that if the beam energy is released on every frequency, the total energy will be infinited. It was physically impossible. Max Planck gave a solution in 1900. Light and energy waves continuously is not emit, but emit in small packets, i.e. quanta. These packets will carry as much energy as high frequency. This leads to energy emissions limited on higher frequency, and the project of infinite energy becomes the solvent. This quantum hypothesis turned out to be perfect, but it didn't understand by the impact 1926 on the deterministic universe. In 1926, Werner Heisenberg appeared a fundamental limitation. If we have to do a comprehensive position of a particle and well-being together, a fundamental problem comes with the position of an object has to be put light on it to the major. The light on is also a wave that has a wavelength. If you use the short wavelength, the position unit will get on the photon's energy will be high, which will distort the particle and change its wellness. If you use the long wavelength, the position will be uncertain on the velocity accurately major. Heisenberg showed that the multiplication of the unsurprising of position and velocity is always larger than the small number called a Planck constant. This rule is applied on every particle regardless of the method to be done. Mean determinism became impossible. If we can't know the present state accurately, the future can't get accurated. The uncertainty principle of Heisenberg broke the vision of the deterministic universe of Laplace. There is no longer a well-defined position of the particles and a quantum state that is a combination of both. Quantum mechanics does not give a single definite ridge, but gives a multiple possible ridge. Each one has a probability. If you repeat the same experiment very often, every result will be a spatial percentage of time. Not every expert outcome can tell in advance. Albert Einstein himself was a large contributor of quantum mechanics to never accept this unpredictability. He said that the universe cannot run on randomness. He said God does not play dice with the universe. On the experts repeatedly showed that quantum mechanics are right and randomness cannot be denied. Today, quantum mechanics is the base of every modern technology. Computers, transistors, electronics, chemistry, biology is based on all quantum principles. At this theory until now a place is not fitted in the pi gravity and large-scale universe. Quantum mechanics showed another strange property, wave-particle duality. Light waves particulars like behaved. Particulars like waves are taken due to the principle of Heisenberg. The mean light and matter are both sometimes particles such as the wave that dips on Sichuan. A famous experiment that delivers this concept is the slit experiment. If there is a partition in front of a screen that has two small slits and light is sent on one side, then a pattern is formed which we call interference fringes. This happens when the light wave is interoperated in the form. Now do this with the experiment electron that is a solid particle, yet the beam wave pattern appears, meaning a single electron is also going together with both slits as it is a wave. It is a proof that things at the quantum level break down the logic of our classic physics. Atomic models of Bohr and quantum mechanics come here. Insurers thought that atoms are small solar systems such as electrons continued to cut off the nucleus dizziness. This electron should fall into the nucleus by loosening its energy according to the classical physics and becomes the tum-chalapse. In 1913, Bohr gave a solution to electrons can only remain in fixed quantified orbit. It seemed to be an explanation arbitrary on. Quantum mechanics explained it well. Electron is not a particle but a wave. If an integer of the wavelength of an orbit electron is multiple, the wave will not interfere and the orbit will remain stable. If there is no interference and wave cancellation, quantum mechanics exploits the microscopy world. General relativity large-scale disassembles universe. But both the theory does not match each other. Where gravity is too strong like black holes or big bangs can't be ignored, there's quantum effects. General relativity without quantum mechanics predicts that black holes and big bangs will lead to density infinite that doesn't create physical senses, meaning a complex theory will be only when we can unify gravity and quantum mechanics. Quantum mechanics can do everything expelling on not gravity. If we have to understand the true nature of the universe, we need a theory that can combine quantum mechanics and relativity to a theory of evergreening. In the next chapter we will see how the scientists are working toward this final goal. Chapter 5: Elementary Particles and the Forces of Nature. Aristotle believed that the entire universe is composed of 4 basic elements, i.e., earth, air, fire, and water, i.e. water. 2 basic forces are gravity and levity. Gravity falls down the earth and water and raises levity, air and fire. We know that this division is incompetitive. Aristotle's bile was that the matter continuous occurs. A piece can be devied in the infinite small part. On the Democrats such as the Greek philog had to say that the matter is granular, i.e. the small invisible units, he said atoms. John Dalton in 1803 supported atom theory. They showed that chemical compounds are always combined in fixed ratios. This is only possible if the matter is organized in small inductible units. But the final proof met in the 20th century when Einstein explained the Brownian motion. The random motion of suspended dust particles in a liquid was the result of the collision of the eccentric atoms. This experiment showed the finalists that Democrats and Dalton were right. The matter discrete occurs. In 1897, J.J. Thomson discovered the electron. In 1911, Ernest Rutherford showed that there is a small nucleus in the midst of the atom with zero mass concentrated. In 1932, James Chadwick discovered neutron. It turned out that the atom was not inductive, but was inside in small fundamentals. Now the question was what the matter is made of particle. In 1925, Wolfgang Pauli gave an important rule that no two same type of particles cannot live in the same state, meaning there may not be 2 particulates with a similar speed and position in one place. This Pauli expulsion principle is very important. If it is not a rule, electrons drop down the same place and collapse the atoms and don't become neutron stars. The complete universe turns into a dense soup. In 1928, Paul Dirac gave an equation by combining quantum mechanics and relativity. They showed that electrons should have an anti-electron called positron. In 1932, Carl Anderson discovered positron and Dirac's theory proved. Today we know that every particle has an antimatter counterpart. If a particle and its antiparticle is found, both are annihilated in a flash of energy. If the whole world is made of antimatter, we and an anti-world can separate ages. The question is why the antimatter in the universe is so rare. As per quantum mechanics, all forces are from the exchange of small fractionals. Matter particles, i.e. electron quarks, fill forces. Force-carrying particles, i.e. Bosonian transmit forces. An electron or quark emits a force particle from it is recoiled. Force-carrying particle reaches the second matter particle, absorb and pushes or pulls the second particle. This force-carrying particles are virtual. The mean directory cannot be edited on their effects appear. Modern physics has 4 fundamental forces. The first, gravity, is the most important force on the most vulnerable. It works everywhere no matter the mass. Gravity is always active so the planet and stars remain together. This is the most weak force, but its range is infinite. This is transmitted from a hypothetical particle gravity according to quantum mechanics. The second is the combination of electromagnetic force, i.e. electricity and magnetism. It works on charging particle like electrons and photons. Photons carry this force. This is the power of 10 times more strong than gravity. It does not create atoms without it and does not light ages. The third is the weak nuclear force that is responsible for radioactivity. It works on electrons and quarks. This is the core set of radioactivities such as beta Dike, W plus W minus and Z boson carry this force. In 1979, Abdus Salam and Steven Weinberg unified the electromagnetic and weak force called electrovect theory. The fourth is the strong nuclear force, which is the glue of the universe. This makes it atomic nucleus by adding protons and neutrons together. Interaction between quarks and gluons occurs. This is the most strong force, but its range is smaller. The strong force has two peculiar properties of the first conformation and the second asympathetic freedom. The confinement is not a quark alone. He has to be combined with each other quark. So protons and neutrals are formed. The second asympathetic freedom, i.e. quarks free on high energy. Physicists is looking for a single theory of aggregation to explain all the forces in the same equipment. Electroweak theory unify the electromagnetic and weak force. Strong nuclear force is also trying to unify the grand unified theory, i.e. but so far the gravity could not fit into any certification. A perfect theory of everything will be only when quantum mechanics and general relativity work together. Once the grand unified theory and matter of the antimatter awesomies talked about the electromagnetic and weak nuclear forces had a more big step to unify the strong nuclear force. Named Grand Unified Theory GUT, but this title is somewhat exaggerated as it cannot explain the gravity so far. It has a few parameters that need to set the experimentally. Theory does not predict itself, but this is an instant step towards theory of everything. The basic idea of the grand unified theory is that the strong nuclear force weak on high energy begins to be. The reverse electromagnetic and weak nuclear forces begins to be strong. At a spatial high energy point called the grand unification energy, the three forces become the same force. Every force that appears different today can be the default version of a single force. This should be at least 1,000 trillion GeV, according to estimates on the compact value address of the grand unification energy. Current particle accelerator can reach just 100 to 1,000 GeV. If an accelerator is created, the size of the entire solar system will be as much as possible. Now the economy doesn't seem to have such an extradition possible, but we can test the low energy effects that the GUT predicts. The grand unification theory predicts a very strange thing, that protons can be deek. Proton, which is the basic unit of normal matter, it can deek spontaneously. In lighter particles, quarks inside a proton can sometimes take extra energy, i.e. due to quantum fluctuations. Protons can be decayed in an anti-electron and another particle when it happens. At this dike is very slow. The signs of being a proton are so low that the lifetime of a proton can be up to 30 years, meaning 1,000 times more time of Big Bang can also take a proton to be taken. How to make an experiment of a lot of protons to ovulate the ever-containing deck detect. The Morton salt mine of Ohino has a 8,000 ton of water expedited so that the cosmic ray interference is low, but there was no proton deck detected any of the experts so far. This means the power of lifetime 10 is more than 31 years if there is a proton dike. GUT's most simple model fails on, and complicated models are the rest. The largest unsolved mistress of the universe is where the antimatter went. Time matter and antimatter equivalent amount of Big Bang should be in. But today is the antimatter almost absent. If there are matter and antimatter equivalent, both annihilates become complete universe is just energy, i.e. light, no galaxy, star, or planet. We just see in the matter universe. So the question is where the antimatter went. An antimatter universe will also ignitely lead as our universe according to the rules of quantum mechanics. Symmetry means that particulates and antiparticulates should be the same, but a shocking was discovered in 1956. The weak nuclear force mirror breaks the symmetry. In 1957, Wu Jiangxis confirmed that the weak force left-right does not follow the symmetry. Then another shocking was discovered in 1964. The weak force also breaks the particle-antiparticle symmetry. James Cronin and Wolfich discovered this CP violation. He found Nobel Prize in 1980, meaning weak force does not treat the particle and antiparticle as one. Antimatter universe matter will be separated from universes. It can be a resonance that the universe is made of not just matter from the antimatter. Another big symmetry is time reversal symmetry, i.e. symmetry. This means that if reverse time, the law of physics will remain the being. If a ball is falling down, then in reverse time he will go up, but the roles will remain the same. On the C-tie theorem, if the CP symmetry breaks, the time symmetry will also break, and the experiment has shown that the weak force time breaks the reversal symmetry, meaning the universe expanding is not a contract. Time is not reversible. It proves that time flows into an irreversible direction. So the concluding is that the grand unified theory does not unify the gravity, but gravity is very important because the large-scale universe controls due to it. Star collapse are made of galaxy and black holes are ageist because of gravity. Stephen Hawking worked on the black holes in 1970. He took the first step to combine quantum mechanics and relativity. It was a glimpse of how a new model of quantum gravity could be developed. In the next chapters, quantum gravity and space-time's deep mysteries will be explored. Chapter 6 Black Holes. Today we look at black holes as a scientific reality, but this idea is old. First, in 1783, John Michell of Cambridge thought that a star will pull up to his gravity light if there is too big and dense. Light will not come out of such object and he will be invisible. Michell rested that such invisible stars can be in the universe. In 1796, Marquis de Laplace also said the same thing, but in the subsequent additives he removed this idea. In the 19th century, the light began to be waved in the Newtonian physics and the effect of the gravity was unclear. Einstein's general relativity 1915 proof that gravity bends space-time and can also uncheck the light. But understanding the proprietor of the black holes came only when the relativity and quantum mechanics had to be combined. A star's life cycle dips on the balance of nuclear fusion. A star is formed from the cloud of gas. Gravity contacts it, causing hydrogen atoms fuse and energy release. This energy creates a pressure that works against of gravity. Star stable remains until the fuel is done. But when the fuel is over, the star's conversion begins. In 1928, Subramanian Chandrasekhar calculated that a star that holds 1.4 times a solar mass or less can become a white wolf. If the mass is high, the collapse can become a neutron star or a black hole. White dwarfs and neutron stars are stabilized from the exclusive principle of quantum physics. But what if a star is bigger than 1.4 times the solar mass? The scientist like Arthur Eddington took this concept absurd. He said that a star cannot shrink up to the infinite density. Chandrasekhar left his work, but found Nobel Prize in 1983. Robert Oppenheimer in 1939 proved that a star can be collapsed until the infinite density. When there is a star collapse, it bends the gravitational field space-time so much that the light cannot escape. This is an event horizon creates a boundary inside which nothing can come back. It doesn't let out a forest that just lets things go inside. After World War II, Oppenheimer started working on the atom bomb project. Black hole theory forgotten until the revival of astrophysics in 1960. When there is a star collapse, his light cone bends inside. A point comes when the light can't be escaped. It is called event horizon. If an object went inside the event horizon, then he cannot come back to event light too. Because the black hole does not light out, we have to edit them in an indirect way. If a black hole is near a star, then his gravity will affect the motion of that star. If a star is walking around an invisible object, then he can be a black hole. When a black hole pulls the matter of a nearest star, he makes a disk. This disk is heated due to friction and excitation emits. Cygnus X1 is a system that has a strong X-ray source that can be a black hole. If a black hole comes in front of a bright object, he bends his light. It creates a distorted lens effect called gravitational lacing. In 2015, LIGO detached the gravitational waves of two merged black holes for the first time. It was a direct proof that black holes activate. Inside the black hole there is a single point in which the density is infinite. Here is the structure break of space-time. General relativity fails here as both quantum mechanics and relativities are separated. A quantum theory of gravity needs to be applied here. An observer who is outside thinks that an object has stopped on the event horizon of the black hole, but in the aquatic he falls inside. It performs a paradox croat that can be a solvent from quantum physics. Stephen Hawking in 1974 practiced that black holes are not compliantly black. The event horizon has a particulated antiparticle beverages croat due to quantum effects. A particle falls into the black hole and the second goes out. This makes black hole energy loose. This process is called Hawking radiation. If a black hole continuous radiant emits, it can gradually evaporate, meaning black holes are not immortal. She can also end up a day. Black holes is a very fascinating topic. The physicals inside them will be the solvent from the quantum gravity. Wormholes and time travel theory is also inspired by black hole physics. Event horizon telescopes like Future Telescope and Gravitational Wave Observatory will give more proof of black holes. The most basic feature of black holes is the event horizon, one such a boundary that nothing can come back after crossing. Nothing can be accelerated by the light as per the general relativity. So if the light cannot be escaped, nothing else can do, meaning a regeneration that gets the effective cut off from the rest of the universe. If an observer is looking at a star's collapse, his experience will also be different because of the relativity. An astronaut standing on the star will send signals to your spaceship every second. When the star event begins to fall inside horizon, the signal of the astronaut will gradually begin to lie down. Observer will take that the signals are shifting to long wavelengths, mean he is getting red. A time will come when the interval of the signals will become so big that people sitting in the spaceship will never see the last signal. The star will gradually fade and become a black hole. but everything will seem normal for those who fall inside the astronaut until he reaches the singularity. But after crossing the event horizon, he cannot come back and eliminates time effectively for him. If an astronaut falls inside the black hole, then the gravity force on his legs will be higher than his head. This effect is called spaghettification. The lower parts of the body of the astronaut will take much force, and it will stretch as a long thin string. By stretching, the finality will be found at the atmospheric level and singularity. But if the black hole will be supermassive, such as the black holes with the center of the galaxy, the astronaut will not feel any noticeable force while crossing the event horizon. He will go in comfort, but he will end as soon as he reaches the eventuality. Roger Penrose and Stephen Hawking proof that a singularity is definitely inside every black hole. Singularity is a point in which the density infinite occurs. Here the space-time is called. It is time singularity. If an object falls inside the event horizon, he will finish by going to singularity. Those who went inside the information event horizon tend to be the compliantly lost. It performs an information paradox which is considered a major conflict of quantum physics and relativity. Penrose proposed cosmic censorship hypothesis of God abhors a NCD singularity, meaning singularity is always hidden behind an event horizon. If the singularities are visible for the universe, then deductibility fails. But as far as the realistic cases have been seen, singularities are always within an event horizon. Hawking also put a bet on the cosmic censorship with Kip Thorne and John Perskill. He lost because some of the mathematical solutions found that the singularity directory can be visually visual, but the singularity from a minor distance in those salons goes back to the event horizon, so there is no chance to be a single singularity necked in the practically universe. Some of the solutions of general relativity tend to create the black hole's wormholes, one tunnel that connect two different points. If an astronaut falls into a wormhole, then theoretically he can reach someone else in the universe or any other part of his own universe. But the worms are highly unstable and the slightest disaster bends can collapse them. This does not mean practically wormholes exam or will not use. Event horizon is a one-way boundary. Anyone can go inside but cannot come out. All hope abandon. In the words of Dante, these who enter here, once the event horizon crossed, it is fixed to reach the singularity. In accordance with the general relativity of Einstein, if a heavy object moves, he will embed the gravitational waves. It strikes the effects of ripple in space-time. The gravitational waves in 1960 was just a theory, but in 2015 the LIGO first documented the gravitational waves of the two merged black holes. It was proof that black holes activate. The motion of the pulsar was also studied. The PSR 1913+16 is a binary neutron star system in which both the neutron stars are walking around each other. In his motion, the predicted changes were seen that were caused by the gravitational waves. It was proof that Joseph Taylor and Russell Hulse received Nobel Prize in 1993. After the black hole formation, he gets settled, but what will look like? In 1967, Werner Israel proof that the size of a non-rotating black hole will just dip on its mass. Roy Keir gave a rotating black hole solution in 1963. Hawking and Brandon Carter proof that the shape of a stationary black hole will just dip on its mass in rotation. David Robinson gave the final proof in 1973 that a black hole will just have the function of mass and rotation, no matter the complicated matter of its formulation. These ridges took up to an important convulsions that a black hole hedge no hair. The black hole is defined by just two properties, mass and spin. Any extras that were time of their collapse are lost, meaning a complicated object collapses and becomes a simple black hole. Black holes' secrets are still helping to solve the conflict of quantum mechanics and general relativity. The concept of black holes was initially a pure mathematical model with no observational proof. The argument of the opponents was how we believe in an object that is evidenced just on a controversial theory, i.e., general relativity. But in 1963, Martin Schmidt discovered a crucial. He made a redshift measure of object 3C273 like a faint star. It was not from the redshift gravity, but from the expansion of the universe. This means the object is far from us and still visible, then his brightness will be at the unimposable level. It was just the same explanation. It is the gravitational collapse of the entire center of a galaxy. This discovery introduced quasars concept, objects that emit energy into extreme amount probably caused by a supermassive black hole. But the objects were so far that it was difficult to find the proof of the directly black hole from them. In 1967, Cambridge's research student Jocelyn Bell Burnell saw another strange thing that was embedding radio pulses on regular intervals. The scientist first thought it is probably the signal of an alien civilization. In fact, was named LGM-1, i.e., Little Green Man 1. But then it turned out that it's the actually rotating neutron stars that are radio wave emitting from the intersection of its magnetic field and surrounding matter. This discovery was very important because neutron stars had an existence proof that gravity can create extreme dense objects. If the size of the neutral stars can be just 10 miles, even more compact objects such as black holes can be. The biggest question of physics was if black hole makes the gravity facts. If a star is walking in the orbit of an invisible object, then maybe he is a black hole. Astronomers saw quite a lot of systems in which a visible star is in the orbit with an invisible compartment. But this invisible object could also be a faint star. It was not necessary to have a black hole. A system Cygnus X1 was also a strong X-ray source. The most logical expression of this was that the matter was released from a visible star that fell towards an invisible object. The matter's spiral motion fell and the extremely hot was getting an experiment. The mass of the unsanitary object of Cygnus X1 was at least 6 times of the solar mass. If the Chandrasekhar limit is seen, it cannot be a white dwarf or a neutron star. The same logical positivity that it is a black hole, but it was not easy to configure everyone. Stephen Hawking took a prerequisite with Kip Thorne in 1975 that Cygnus X will not have a black hole in the forest. The whole work of the Hawking worsens if there is no black hole, but at least he enjoys him by winning the bet. But when it comes to proof, Hawking conceded and gifted Kip Thorne a 1-year subscription to the Penthouse magazine. Simon's X1 as well as multiple systems were observed. Some black holes are in our Milky Way and some like Magellanic clouds in Nebulating Galaxy. This number can be very much. A lot of stars' universe's history will have collapsed after the fuel is over. The number of black holes can be more than visible stars. The galaxy is rotting because of their extra gravity. Milky Way center can have a black hole which is 1 lakhs of solar mass. If a star went close to it, his tidal force will be broken. The matter who will survive will go to the black hole in the spiral motion and will emit radio and infrared waves after heat. This is what we are observing from the center of the galaxy. There are also supermassive black holes such as the central black hole of galaxy M87. Hubble telescope saw that M87 has a rotating gas disk that is circulating around an object with a 2 billion solar mass. This object cannot be anything other than a black hole. Black hole also rotates when the matter falls into a supermassive black hole. This rotation generates a magnetic field that ejects high-energy particle into a beam form in space. The observation of such jets has also been in the galaxy and a quasar. Black holes with a small mass cannot become from a normal stellar collapse as stars are not collapse under the Chandrasekhar limit. But such black holes can become if the matter is compressed to extreme pressure. John Wheeler had once calculated that if all of the world's ocean's heavy water can become a black hole if a large hydrogen bomb is formed by collecting a place. But there is obvious, there will be no escape that observes it. Another positivity was primoball and black holes. According to Einstein's general relativity, the gravity quantum physics could lead to small regularities in space-time in the initial moments of Big Bang. But the existence of the galaxy and stars proof that early universe had irregularities. If this irregularity was considerable, then some regions could be overdues and become primordial black holes. These can range from 10 tons to 10 lakh tons. Black holes just do not light absorb, but also slowly emit energy. It is called energy Hawking radiation. Small black holes will evaporate for much faster rate. In this concept next chapter we will try to understand in detail how the black hole is not just a trap, but a dynamic system that also interacts in the universe. Chapter 7 Black Holes and So Black. Stephen Hawking's work before 1917 was on proving the mostly Big Bang singularity. But when his daughter Lucy was born, he began to think about black holes. Because of their disability, it turned out to be easier to get into beds, becoming a best time to think for them. At that time, there was no clear mathematical rule of defining the black hole. Hawking disclaimed with Roger Penrose that a black hole should be treated with events from which no light or matter can exit. The boundary event of the black hole is horizon. It defines the foot of the photons that do not escape. One way is the edge of a shadow. Then Hawking said a strange thing. The light ray to the event horizon can't go to each other or she will get, and if she got it, it means she will move inside the black hole. But if he walked inside the black hole, he cannot be on the boundary of the event horizon. Meaning black hole's event horizon will stay in either being size or will never be shortened. It was very important discovery. If the new matter falls in a black hole or two black holes merge, then the event horizon of the final black hole will always be bigger than ever. Hawking saw that the size of the event horizon twitches. Another thing that is the entropy. Entropy is major of disorders. Entropy always grows according to the more entropy, the second law of thermodynamics. As if a room is left, it will gradually go down. Hawking saw that the area of the black hole always grows exactly like the entropy. Princeton student Jacob Bekenstein rested that black hole's event could be the measure of horizon entropy. The area of the event horizon increases if the entropy goes into the black hole. It can avoid having a valuation of the second law of thermodynamics. But Bekenstein had a problem that if the black hole keeps the entropy and some things keep the temperature, then he embeds the radiation. But black holes do not embed anything, then how can the entropies concept apply to black holes? Hawking was not angry. He wrote a paper in which it tried to digest that the entropies do not turn away from the black holes. But Bekenstein went outright, in a way that no one thought. During the Moscow visit in 1973, Hawking took discus from two Russian scientists, Yakov Zeldovich and Alexander Starobinsky. He said rotating black holes particles should embed according to quantum mechanics. The physique was right to the Hawking, but the mathematical proof did not like. He began to solve this problem with himself. He had an expectation that just rotating black holes will embed the particles. But when he had his calculation, he got a shocking result. Not just rotating, but also the same stationary black holes emit radiation, and this radiation resembles a hot body's radiation. This exactly follows the same emission rate, which should prevent the verification of the entropy. Meaning black holes pure black does not mean she slowly embed radiation. As per quantum mechanics, ambient space is not empty, there are small quantum fluctuations. Sometimes a particle becomes an antiparticle drinker. Normally he destroys each other, but if it is on the edge of a black hole, there is a strange thing. One particle can fall inside the black hole while the second particle can exit. If there is a partial negative energy that falls inside, the black hole mass begins to gradually reduce, and that the particle exits becomes a real particle that is seen remotely. The black hole is released. This radiation is called Hawking radiation. There was a shocking implication of the Hawking radiation that the black holes are not immortal. The smaller the black hole will be as soon as it will evaporate, the larger the slower the radiation will emit. But as a black hole will loosen the mass, the temperature will increase. A point will come when it will be so hot that a final expulsion will make full energy release. It can be as powerful as blast millions of hydrogen bombs. It was a very large paradigm shift. The first people thought that the black hole is just a trap that falls anything, then it never comes back. But now it turned out that black holes themselves are also slowly evaporate. If the Hawking radiation is right, this means that all black holes will be evaporated a day. It was the first true overlap of quantum mechanics and relativity. Another big question arises if the black holes are evaporate wherever the information falls into the black hole. Can he finish or return in some way? This is the question of the information paradox that has not been so long. If a black hole has a couple of times of the mass flux, then its temperature will be just above a millionth part degree of absolute zero. This temperature cosmic microwave background radiation that is above 2.7 degrees Kelvin absolute zero. This means that the black hole will absorb more than it will emit. If the universe is always exaggerated, one day the temperature of the cosmic radiation will be lower than the temperature of the black hole. Then the black hole will gradually begin to evaporate. But this process will take a lot of time that is difficult to think about. The power of 1066 years. The power of 10 years, which is the edge of the universe, is several thousand times more than 10 years. The big blacks that mean today will not be the moment evaporate. If the primary black hole is made by small regularities collapsing in the early universe, it has been completely evaporated so far. Such evaporating black holes are exercising and gamma rage emitting. It is black hole, but also white hot. It is energy fired up to 10,000 MW every second. One such black hole can run 10 nuclear power plants. A primordial black hole is heavier, but as small as a nucleus of an atom. If he is on Earth, he immediately falls inside the ground and oscillates between the Earth until the center is settled. If you have to use this, you have to put it in an orbit in the space. Towing it in some way, you have to take it to the orbit as a carrot is hung before the donkey. This is currently an unrealistic idea. If this is a primordial black holes present, we can edit them through a gamma ray. We see a uniform gamma ray background. If the primordial is not black holes, then the effect of gravitation should be primordial black holes. 1 billion kilometers of black hole Pluto, nearest, if he is more common in million times. But it's difficult to detect his radiation from this distance. We must have a very large gamma ray detector which is in space. If such a black hole Pluto is easily visible on the end of your life at a distance. But if he has been giving a radiation for 10 years, then the chance of being an extradone in the next few years is very low. This means it's difficult to have a directive. Satellites was launched to edit the futures of test ban treaty during Cold War. He saw that gamma ray burst is getting 16 times every month. This uniform is scattered in sky. This means either in our galaxy or another place. If it is outside of our galaxy, their energy level is too much that is not possible from the tiny black holes. It can be the exploding black holes if it is in our galaxy itself. But another explanation is that it's happening from being the colloid of the neutron stars. New gravitational wave detectors such as LIGO Future can solve this mystery. If we don't find primaball in black holes, this means that early universe was the perfect, smooth, and uniform. Too much primordial black holes are formed if he is irregular. If they didn't have a formation, this means that the initial conditions were absolutely stable. The lack of mean black holes is also a discovery. When Hawking first released the idea that black holes radiant could get rid of all, in the conference in Oxford, people were not confident when Hawking appeared their calculations. John G. Taylor, chairman of the sessions, said it is complete nonsense. He also wrote a paper that was the August of Hawking, but the finalist became Taylor and the rest of the physicists agree. If quantum mechanics and general relativity is correct, black holes will have to remove radiation. If an astronaut falls into a black hole, then his mass will be added to the black hole, but because of the Hawking radiation he will slowly return to the universe. Astronaut will be recycled back in a way, but his conscience says and memory will go forever, meaning she will be a useless immortality. Not just the mass will come back. A point from the Hawking radiation will come when the black hole will be so small that he will be complete evaporate in a final blast. When the mass of the black hole is less than 1 g, the calculation of the Hawking can fail. Black hole simply disappears. And if the singularity disappears, it does not mean singularities in quantum mechanics. Hawking in 1975 gave a seminar on the quantum effects of black holes. After that, he and another physicist began to develop a new epoch of quantum gravity. He used the over-history method before Richard Feynman. If the quantum gravity becomes a solid theory, it can give us a new model of the original and future of the universe. In the next chapter we will dissipate on how to explain quantum physics and gravity together. Chapter at the original and fat of the universe according to Einstein's general relativity. Space-time started with a Big Bang singularity and its end will either be on a Big Crunch singularity if the entire universe is back collapse. If a local regeneration like a star collapse and a matter falls into a black hole, he gets destroyed in a singularity and just his gravitational force feels out. With quantum effects it is possible that the black hole returns its energy slowly to the universe and finally evaporates. Big Crunch can also have the same effect. How it will look if there is any beginning and end of the universe. Hawking in a Vatican conference in 1981 showed his interest on the originals and facts of the universe. The Catholic Church had already been mistaken in terms of science like Galileo. At the end of the conference, Pope said it's okay to study the universe after Big Bang, but not to find the cause of Big Bang as it was the movement of the creation and it's just the work of God. Hawking was happy that the Pope did not know that his lecture was on the same topic. Hawking gave a revolutionary idea. If space-time is a finite, but there is no boundary, this means that there is no definite beginning of the universe. The temperature of the universe was very high immediately after the Big Bang. Just as the universe expanded, its temperature decreased. The temperature is half when the size of the universe is 2 times. Just as the particles were cold, they began to untreat each other. Particle-antiparticle drinkers from collision on very high temperature. But as the temperature fallen, the isolation of the particle-antiparticle drinkers began to be higher. If we go back, it comes a time when the size of the universe was gyro and it had a temperature infinite. Temperatures after a second fell to 10 billion degrees. At that time the universe photons was filled with electron neutrinos and their antiparticle. When the universes and cooled, electrons and positrons began to be annexed, but neutrinos and antineutrinos escaped. If the neutrinos has a little mass, it can be a part of the dark matter that can collapse the universe back. The temperature drops to 1 billion degrees after 100 seconds. Proton and neutron could no longer escape from the nuclear force. Heavy atoms of hydrogen, i.e., deuterium and helium, began to become nuclei, converted to 25% matter helium. The nuclear recepts was predicted by George Giozzo and Ralph Ulfer in 1948. He told that this ancient reaction should still be in the universe as a cosmic radiation today. Penzias and Wilson in 1965 discovered it in cosmic microwave ground radiation. It was a big proof that Big Bang model is perfect. After a million years, the universe was not doing something special, just being expanded. Some place was matter a little dense in which gravity began to stop expulsion. It began to be a regeneration collapse and became the galaxy. The spiral galaxy which got rotation to the galaxy. The elliptical galaxy built without rotation. After that, the small gas clouds inside the galaxy were collapsed with hydrogen to be replaced in helium. Large stars quickly finished their end in a supernova exfoliation. This exfoliation make new elements like carbon, oxygen, and iron. Our sun is also the star of a second or third generation composed of supernova debris 5 billion years ago. The Earth was initially warm without atmosphere. gently drained gases and made atmospheres, but there was only hydrogen sulfide-like posing gases without oxygen. The first primitive life in the sea that combined these gases. This process began to release oxygen that was born a new environment. After that, life was evident. The fisherman was born by mammal and finally human. Big Bang model expels a lot, but some big questions are still left over. That the universe was initially so hot. If Big Bang is a normal expansion, then how much temperature came? The second universe is so uniform. Why is the temperature of all the space almost the same? The light could not be reached from one corner to the other corner according to the relativity. How this synchronized happened. The third exchange rate is so perfect. Universal collapse is done if the expansion rate is less than just 10 power minus 18% after a second. What is the cause of so processing tuning? And the fourth of how the seeds of the galaxy and stars remained. Early universe was smooth, where the density flexions came from. If it is not fluctuations, the galaxy does not become. Hawking and new physics quantum were thinking of combining mechanics and relativity. The Big Bang can also do if the quantum mechanics can change the black hole. Quantum gravity can give a model that can tell the true of the original and future of universe. General relativity is just a classic theory that can't predict next to Big Bang singularity. All the rules of science fail on singularity, so we need quantum mechanics to know how the universe started and what the future will be. Hawking questioned how it started if the universe runs on fixed rules. Did God just fix the condensations of the beginning of the universe and then let him walk according to the rules? Where there is no boundary of space-time. An offer was that the boundary condition of the universe is random, i.e. different boundary condiments. This meant every regenerations until state executed a random probability. Uniform is very different if it is true, not uniform. There are a lot of primordial black holes that don't match the ovulation of the gamma-ray background. There was another proposal that if the universe is infinite or there are several infinite parental universes, then there may also be some regeneration smoothies and orderly. This is the exam of the mankind with a typewriter. Most often he will write random letters but can sometimes write as Shakespeare's gold. Are we living in an orderly regeneration just made of a random chance? Why the universe looks like this? The answer to this question is in the anthropic principle. According to the weak anthropic principle, if the universe is too large or infinite, then only a few surgeons will be where the development of life is possible. We're just looking at it because we're in a regeneration that adapts to life. And there are a lot of different universes according to the strong anthropic principle with each one's own set of law. Some universes have rules that make intelligent life possible. We're just asking this question as we're in a universe that's suitable for life. We are not only if the law is different. Hawking also says whether it's a divine plan or just a cosmic accident. Is the selection of natural law a random process? Electrons' charge, proton-electron mass ratio, or the strength of weak force, its values are so precise tuned that if it's a bit different, stars and galaxy doesn't find it. If the charge of the electron is different, either the stars are not a bit of burning hydrogen and helium or are exfoliated. A lot of universes do not have intelligent life possible. This fine-tuning problem stands a big philosophical question. Is it all made in accordance with a plan or only life in the same universe that fits everything? If there are different universes, they will have no connection in themselves. There will be no way to move from one regeneration to another if there are different regions of the same universe. If there are different rules everywhere, a smoothly move from one rage to another cannot be done. This means that the principle becomes just a philosophy, not science. Hawking raised another objection. Science always promotes geocentric, i.e., Earth-centered and human-centered thinking. On the strong anthropic principle, it says that the entire universe just made to be ours. What trillions of galaxies are just for our ability to think? It is difficult to believe. The temperature of the microwave background, according to the Big Bang model, is all the place alike. This can happen only if the initial conformations are exactly the precision tune. The exemption rate is also the perfect set that it is not much slower than it's fast. If you start a random process universe, then perhaps the intelligent life is never possible. Another theory that seeks to solve this problem is the inflation theory. Alan Guth, who was the scientist of MIT, he said in 1981 that early universe can undergo a rapid expulsion phase. The radius of the universe at a time increased a million times a time less than a second. It is the inflationary universe model. Big Bang started in a high temperature and separate state. The weak and strong nuclear force and electromagnetic force on very high energy was the same force. As the universe cooled, had a phase transition in which the forces separated. It went to a supercooled state, replacing the phase transition smoothie. Supercooled was an extra energy component of state that was working as an anti-gravity. This force had a repulsive effect which led to a expand in the universe's exponential fast rate. There was a huge impact of this inflationary exemption that the smallest regularities had become rapid smooth. When airing in a balloon, his wrinkles are hidden. So today we see the universe so smooth and uniform. The inflation model gives a psychotropic way that tells how a random ideal universe can also turn into today's structured universe. If the inflation theory is right, a lot of essential states can create a similar final universe. This is a beater from anthropic principle as it gives a psychotropic model that can visually expel the galaxies, stars, and life. Hawking believed that if the inflation theory is right, we would not need any differential intervention or perfect tuning. The beginning of the universe can be expelled in a psychotropic manner without any external force. Inflationary universe proposes a model in which the expansion of the universe is expelled from a cosmological component, rather than having a slower than a gravity. One of the biggest benefits of this is that the inflationary expansion means that the early universe had a light trade between different regeneration. It also means that those who are far away from each other could still devalue a similar property. This allows us to understand why the temperature is the same in every direction of the universe. Another big problem is also solved. The expansion of the universe after Big Bang remained very close to a critical rate. If this is not an inflationary exemption, there is a very careful tuned essential condition to understand this. Another big question is where many particles came in the universe. We see that the power of around 10 in the universe is 80 particulates. According to quantum physics, can become particle anti-particle drinkers from energy. But where energy came from? Hawking pointed out that universe's total energy is zero. The matter's particles inside the universe are made with positive energy, but this matter acts and mutually generates a negative gravity energy. Both cancel each other, which leads to total energy zero. So in the universe can become free radicals without any external energy. As an accountant wrote zero in the balance sheet and then writing equal numbers on both sides. Guth said a fun thing about the universe as the ultimate free lunch. Today the universe is almost in critical exemption. It means that a mechanism would have worked to change the exemption. During the inflation there was a high energy phase with forces symmetric. As soon as this symmetry broke, an extra energy released which reheated the universe. After that the universe followed the normal Big Bang expansion in which he gradually cooled. Now we had an expression of why the exposure of universe was so close to the critical rate and also why the temperature in different regeneration is so simple. Guth's original inflation model worked as a phase transition. Just as cold water becomes a sudden ice, one can eliminate the inflation from the sudden transit. But a big problem was that this phase transition occurs in small bubbles. The exchange of universe was so sharp that bubbles were not found to be going away from each other. If the inflation is similar, today's universe is not a place uniform, but in different phases. Andrew Lind took this problem during a conference in Moscow. He said that if there is a large bubble during the inflation that we have completed visible universe, it can be a problem solvent. Then another problem I should be bigger than this bubble universe. Hawking proposed a new model for that symmetry breaking takes place together everywhere instead of becoming bubbles. This means a smooth universe when the inflation is over. This led to the problem solution to how the regeneration uniforms occurred. The model of Lind went in a new direction and the new inflationary model was born. Another team was Paul Steinhardt and Andreas Albrecht, University of Pennsylvania. He also proposed similar models of independently. These three together got credit for the new inflationary model. The old inflationary model had fast symmetry breaking on the new models and slow symmetry breaking. But this new inflationary model was also not perfect. The Hawking and the other scientists showed that the model, the fluctuations in the microwave background were much higher than reality. And in the quantum field theory, doubt began to come whether the visa phase transition could be true. Hawking said that these models were the scientific theory at the time, but now they have died because they don't match new data. Lind proposed another new model in 1983 called chaotic inflation. This model does not have any phase transaction. A quantum field that drives the inflation. The quantum fluctuations keep the field much energy in some of the regions, thereby inflation. Once the inflation is over, it is converted to energy heat and a Big Bang expansion is normal. In this model, all inflationary models were uninterrupted without any incomplete style. This model features a realistic size fluctuations that match microwave background observance. So today, the most adapted form of the inflationary model is the chaotic inflation. A large advantage of the inflationary theory was that there was no need for an original state of the universe. A lot of different essentials could come from the inflation to the final state. This could mean the weak anthropic principles used to understand why the universe looks as well structured today. If the inflationary theory is seen to go back, not a well-structured universe is formed from every essential condition. If there is a lumpy and irregular universe, it remains the same after the inflation. So there is a role of essential condition that is not just the inflation alone. Hawking also pointed out that if the inflationary model is not a perfect theory, would we have to opt for anthropic principle? Is it all just a random chance? If we become dependent on surf-lucky excellence, it would be a way to defeat science. We need a law to observe the starting conditions of universe that work on the bending of time too. If general relativity is just right, there is a singularity in accordance with Penrose-Hawking theorems in which everything breaks down. But if the quantum mechanics are also included, then maybe the singularity can be a powder. We need a quantum theory of gravity to explain it. Classical theory of gravity has two possibilities: either the universe was always started by the infinite past time or on a single singularity, i.e. at a finite time. But quantum gravity shows a third probability. Time becomes another space-like direction from the concept of the Euclidean space-time. This can lead to space-time finite without any singularity or boundary. Understand the surface of the Earth is finite, but there is no edge anywhere. If your cell don't just fall back, there will be no start or end if space-time is. Hawking said the boundary condition of the universe is the hedge no boundary, i.e. there is no starting or closing of universe, just a self-continuous entity that is just. Singularities may be a powder in accordance with quantum theory. If the Euclidean space-time is transported to the imagery time, then we will not need any new law or God for the commencement of space-time. No one has to do a special boundary condition to find. Hawking first published this idea in the Vatican Conference, but then it was difficult to understand its observations and implications. Refined this theory in Cambridge, later coupled with Jim Hartle. Hawking and Hartle showed another instant aspect of no boundary proposal. If we use quantum sum over history, we can see which of the possible universe is the most probable. This revealed a space-time model that heals like a shell. The universe in this model starts from a north pole from a point. As the imagery proceeds in time, the universe expands maximum size, i.e. the waiter reaches back to the contactor on the south pole side. But there is no singularity here, as there is no sharp edge on the earth pole. Law of physics work everywhere without any singularity. If you look at real time, it will look like a big bang that has a universe expand. Once again, can also be a big crunch. In real time, the singularities will be visible, but at the quantum level they are removed. Hawking said it great fun. That's probably the real time we've understood the imagery time, and what we think real time is just a concept that we've created to understand. Different possible states of the universe are condensed in a summer over history. Every single history is a compact space-time and people living in the galaxy and playing it. Anthropic principle can justify why we are in a history in which life is possible. If the no-boundary condition is correct, we can predict that the exposure of the universe should be the same in every direction and its probability should also be high. This is what we see in the observation of the microwave background radiation. In 1992, the comparisons of the COBE satellite conferred that the universe considers exactly as per the provisions of the inflationary model. The small density fluctuations also appeared that were expected because of the quantum uncertainty. It was a strong evidence that no boundary proposal could be a valid scientific theory. So what is the role of God? This idea picks a very large philosophical and reliably debate if the universe is self-contained. If universe is self-contained without any boundary, then what God needs? In the classical cosmology, if a definite came from the beginning, one has initiated it. That is, the concept of a creator fits the logicality. But if the no-boundary condition is right, the universe has never started, it was always, then no one has worked to start it. Hawking said an iconic line on the same EFF: the universe is self-contained, having no boundary or edge, it would neither be created nor destroyed. It would just be. According to Hawking, no boundary proposal means that there was no definite boying or creation of the universe. Hawking does not directly redirect any reliance standpoint. He says that if science shows a self-contained model that understands universe, then no need for a supernatural intervention. There is also another philosophical thinking on which if the no-boundary condition is a perfect explanation, which also created these laws of quantum gravity that are so accurate, can it also be a part of a design order? This debate is still running today between both science and philosophy. Is universe a random result or an intelligently desired system? Even if there is no creator, the question remains that universe's roles is so perfect why we can do the same as beings. Hawking delivers just a psychotropic supplement in their books. It is not proof that God is not on it, tells that may not be needed. Hawking once said that science as increasingly answering Queen's Theat used to be the provost of release. It was a considerable revolutionary idea that there's no absolute beginning of universe, just a self-sustaining reality. Chapter 9: The Arrow of Time. First, people believed in obsolete time. Every event could be labeled by a unique time number. All clocks showed the same time. But the relativity theory reported that every observer has its own time. The clocks of people with different speeds will not be aggregated from each other. Then the quantum gravity in which the imagery time concept came. Imaginary time-space is like You can go ahead even behind, but the past and future look different in real time. We can remember the past but not the future. The past and future in the real world does not seem like a time appears in a direction we call time arrow. There are three types of arrow. The first thermodynamic arrow is that the disorder is always increasing. The second psychological arrow, we can just remember the past but not the future. And the third cosmological arrow, i.e. the universe expanding, is not the contact. Hawking said that no boundary can be understood from the proposal and weak anthropic principle why this three arrow is in the same direction. Second law of thermodynamics says that the entropy disorder always grows. Understand from an exam can break down from a cup table but don't break back. If a movie is reverse, it will be revealed that it is unnatural. This means a definite direction of the time of the endotropy, and he always proceeds. Entropy's rise directly means that the universe is going from a high-order state to a low-order state. If the entropy can be reducible, the broken cup can be added back, but it does not happen in the real world. This means the universe will begin with a spatial insurance condition from a high-order state. Why can't we make future memories? Why not we can know today's stock market results? The answer is from the memory of brain and computers. Memory is stored in an order state, but this process contains energy consumer and increases the disorder. We can only create memories in the same direction in which the entropies are growing. Collect a computer memory access. If the beat of an abyss can be either in the left, either in the right, the state of India must have energy to be defined. Entropy grows from being an energy emit. We can remember only in the direction of increasing the entropy and just remember the past. Another question is why the growth of the entropies and the expand of the universe is in the same direction. If you look at the classical relativity theory, you can't be prompted how the universe started. Universe came from a highly ordered state or had previously disorders. This cannot be construed, but according to quantum gravity and no boundary proposal, the universe started from a smooth and orderly state. Quantum fluctuations put a little non-uniform that regenerates the galaxy and stars. It expels why the expansion of the entropy arrow and universe is in the same direction. What if the universe goes into the traction? Will the entropies become vomiting? Hawking first believed that the entropy could be reversed, but later he accepted that it is wrong. The universe, whether the contact is, the nitrope will always continue to grow. What time will be reversed if the universe has ever been contacted? Or if someone falls into a black hole, then can he see time reverse? Can he make money today by seeing the stock market of tomorrow? Hawking said this is just a science fiction. The astronaut falling into the black hole will not see the reverse of the entropy. His time arrow will remain the same as in the expansion phase of the universe. Entropy is growing if the universe is getting expanded. Intelligent life is possible as long as the universe is expanding. If you will contact, then there will be no strong arrow of the entropy. That's what we're living in an expanding universe because an intelligent life expert cannot do the same in a contacting universe. That's what we're in a phase that entropy is growing and the universe is expanding. Both are in the same direction. The law forward and backward time of science consists of a similar but three arrow of time up here. Increases thermodynamic arrow disorder. Psychological arrow is that we can remember the past but not the future, and cosmological arrow that is becoming the universe expand. We look at the time in a definite direction. We can only create memories in the same direction in which the disorder is growing. The expansion of the universe and the growth of the entropy is in the same direction, so we can act. If the universe will contact, the time will remain the same. Hawking said that if you read and remember the whole chapter, the order increased by 2 million units in your mind. But you've done so much energy consumer that disorder grew 10 million times in the universe. This is the simple example of the entropy. As the knowledge is growing, the disorder of the universe is also increasing. Time arrow will always go ahead and we can live in the same direction. Chapter 10, Wormholes and Time Travel. Is it possible to travel in time? In the last chapter we saw that time seems like a straight rail track that we can just go into a direction. But what happens if there are loops or branches in this track? Can we go to the past or future? The Time Machine of H.G. Wells' like science fiction novel has expelled this idea. But as submarine and moon travel were ever just science fiction, what time travel can also become a day science fact. For the first time in 1949, Kurt Gödel found a new space-time model of general relativity that allowed time travel. Gödel's space-time shows the entire universe in a rotating frame. If the universe is rotating, then a person could return to the rocket by flying back before his journey. Einstein did not understand, as he never thought that general relativity may allow time travel. But Gödel's solution does not apply to our universe. Cosmological constant zero was considered after the proof of the expansion of the Hubble. Observations show that the universe may not rotate, so it was a hypothetical model of time travel. But even more space-time structures are found that the time travels are the theoretical. as the interior of the black hole, or two cosmic strings that are passing through high speeds to each other. Cosmic strings are very thin and long objects that occur in tension, about a million tons. It can distort space-time to create time loops. Our observances show that there was no such curvature in ancient universe that support time travel. No boundary proposal also shows that universes do not hold from the beginning of such a structure. No object light speed can be accelerated according to the relativity theory. If we send a spaceship to the nearest star Alpha Centauri, it will take 8 years to arrive there and come back. If we go to the center of Milky Way, it will take 1 lakh years. But there is a small tightly that an astronomer, according to the twin paradox, that would go to then space travel would be much younger when it came to a period which is rushed on the Earth. But if she returned thousands of years later, her friends and family will have died quite first. So science fiction writer faster transactions use light travel. But if we can travel the faster transaction light, we can also go to the past as per the relativity theory. The relativity says that if an object goes up to the speed of light, he needs the infinite energy. Particle accelerators show that we can reach 99.99% speed of light, but not beyond. What can be a shortcut if the faster transaction light travel possible is not? Einstein and Nathan Rosen gave an idea in 1935 by wormholes, or Einstein-Rosen bridge. A wormhole is like a thin tunnel that connects two different space-time regeneration. If a wormhole is from the solar system to the Alpha Centauri, the distance of 4 light-years can be fixed in just a few million miles. But there is a big problem. Natural worms aren't stable. He immediately gets collapse. If a civilization is advanced, perhaps he can open a wormhole. But negative energy density should be taken to distort space-time. Classical physics says that negative energy cannot be density, but quantum mechanics says that quantum effects can allow negative energy density. The Casimir effect is an experimental proof that negative energy density Angus performs. If we make a time travel day, why not the people of future come to visit us? There are two possibilities. The first, future people are hiding the secret of time travel. The second, chronology protection congestion, i.e., nature itself prevents time travel. Contaminations will occur if the past change can be done. You are not born if you kill your curtains. If you come from a future, give the Nagy a nuclear bomb, how will the history change? There can be two solutions. The first component, history approach, that if you went to the past, you will do exactly what is written in history, you will not be able to change anything. If one has traveled time in the past, we have seen the effects of ality. The second is the alternative history hypothesis, i.e. the multiverse theory. You will be in a new alternate timeline if you go to the past. You will create a second history that will change your original way. Back to the Future movie is built on the same idea. Quantum mechanics has a time travel at the microscopic level. Particles and antiparticles can cancel each other. Black holes' radiation emit can cause quantum effects. But will it be possible even at the microscopic level? The chronology protection congestion of Hawking says that the energy density of space-time will increase due to time travel, so that it will become collapse. This means that the nature itself prevents the passage in the past. Hawking said that if the time travel is possible, someone came from the future and I was challenged. Wormholes and negative energy density theoretically can support time travel but are practical and logical contractions. Perhaps the nature itself has made time travel the impossible. We just have an option to wait for the future. Chapter Roman 11. The experiment of physics. Can a theory explain everything? In the first chapter we saw that creating a compliant unified theory is a very difficult task. Science has made progress by creating a mutual theory that expels different processes. As the intersection of the chemistry atoms explains the inner structure of the nucleus without understanding. Physics made different theory for different forces. A final theory should be the one who can perform all the forces and particle interactions. No one has to put an unknown component or number. This is the main goal of the unification of physics. Albert Einstein was engaged in finding a unified theory until his last life, but not success. At that time there was a lot of knowledge about quantum mechanics. Einstein did not believe in quantum mechanics. In their time only two fundamental forces knew, gravity and electromagnetic force. But the knowledge of nuclear forces, strong and weak, was not there. Einstein's thinking was too far ahead for that time, but the time was not right. Today we know more, and so the possibilities of integration have increased. Even before, people think that science has reached their last knowledge. Max Born said in 1928 that the physics will end in 6 months as the electron equiment of the Dirac came. But the entire model fell when neutron and nuclear forces were detected. Even today we can find a potential grand unified theory, but we cannot be completely required. So far we've got 3 fundamental forces with quantum mechanics: electromagnetic force, strong nuclear force, and weak nuclear force. They have become a grand unified theory, but the inclusion of gravity is not in it. General relativity is a classic theory. Quantum mechanics follows the uncertainty principle. Both of them have difficulty in mixing. When the quantum effects were tried to put in gravitation, a major problem is in front of the infinity problem. Virtual particulates in quantum vacuum are always formed and emit. These are the total energy infinite. According to the general relativity, it will make the infinite mass crate which will take the space-time to the infinite curvature. But we see the space right and smooth. It shows that quantum mechanics and general relativity are the opponent of each other. In 1976, a new idea came: supergravity theory. In it added particulates containing spins 3/2, 1, 1/2, and 0 with gravity, i.e. spin 2. It gives an unified framework that also includes quantum effects. It had concepts to cancel negative and positive energy of virtual particle, but some of its mathematical calculations were very difficult. Take 4 years to perform a calculation. If a mistake has been done again, so someone did not verify it. Even then, people felt that supergravity can be the right way. The idea of the string theory began in 1984. Supergravity had particles point-like, but it's small strings in the string theory. These strings make vibrations that we see as particles. Strings can also connect and break. The quantum gravity can also be understood, but the string theory came with a new problem. This is just a condition when space-time has 10 or 26 dimensions, but we just look for 3 space and 1 time. The rest of this solution is very small, i.e. compaction. In 1994, a new idea further strengthened the string theory. Particles are 0 brains. Strings can also be objects of 1 brain and higher dimension. Different string theory can be the default authentication of the same ultimate theory. It tells us that we will not get the same theory, but many theory team will create a complicated model. There may be 3 possibilities. A compliant is the unified theory possible. A day we will get a theory that will expel everything. The second will be an infinite series of theory, i.e. new layers will be met with new discoveries. And the third is not a theory, that is, universe is completely random and arbitrary. But quantum mechanics delivers that randomness limited is. We can't get everything from accurately, but randomness follows a spatial rule. What if an ultimate theory is found? A man at Newton could understand the complete physics. A specialist can also just understand a short field today. The simplified version will be taught by the school level if the unified theory got. But will we ever know all the rules or make new layers out? It's just a beginner that we know today. Chapter 12, Concussion. We are living in a strange world. What is the nature of the universe? What is the place in us? Who created it and why made it? How to make it? Why it is this form and why not something else? We create a world picture to give an impression of these questions. As in the first time people believed the earth was hinged on the back of a large turtle. So today we consider models like superstring theory and quantum gravity. But none of the theory can become a scientific theory until it is certified. In the oldest time, people believed that nature controls the deity. Sun, moon, mountain, rivers, all viewed as a living form. Yajna and Bali were given to please these gods. But a strange thing was observed over time. Sun rises every morning and every evening without any force or sacrifice. Moon and planet nakshatra follow a fixed path, the nature moving according to regular rules. That was the beginning of knowledge that universe is running from a rule. By the 19th century, people began to feel that there would be a universal law that can detect every event. At any time we know the full data of universe, we can tell the whole future. It was the idea of scientific determinism. This means that everything is going to be in a fixed way without any random event. But this theory had 2 big draws. It was not reported where this rule of universe came from, which of the universes began in the condition. Laplace assumed that this thing will be chosen by God. God could make the rules of universe but did not interfere in the midst of him. Quantum mechanics lasted the determinism of Laplace. Any particle velocity and position cannot be addressed simultaneously in accordance with the uncertainty principle. Particulars are not at one point, but rather like waves. Randomness is a fundamental feature that prevents any theory from committing 100% accuracy. This randomness is what God's intervention. It may be that we are misunderstanding the concept of the particles and waves. The rules of gravity in this book were seen in particular because gravity is the weakest force, yet it decides the large formats of the universe. The rule of gravity says that the universe cannot be static, will either expand or contract. One time will happen as per the general relativity when the universe was the infinitely dense. There are points where all the rules of physics fail. A new idea came out when the quantum mechanics and general relativity were seen. Time and space can be a finite 4-dimensional structure that is without any boundary. Just as there is a shell of Earth, a 4-dimensional structure can be of the universe. If the universe is absolutely self-contained, then whether the Lord has a role in it. Einstein once asked how much discount the Lord had in creating universe. There was no discount if the no boundary proposal is correct. There may be only one self-consistent theory that gives the opportunity to understand that beings like human. A theory is just a set of integrations, but the question arises why these units disassemble the universe. Does it exist automatically, or a creative force run these? And who created it if a creator is? The question of why it is not so much explored in science as many questions have been made. There was a time when philosophers worked in all areas of science and knowledge. From Aristotle to Kant, all considered the rules and beginnings of the universe. But as sciences were more intensive and mathematically, philosophy left behind. Philosophers such as Ludwig Wittgenstein in the 20th century just became limited to the language analysis. But if we find a complex theory, it's not just a matter of scientists selected. All people will consider this together with the scientist, philosopher, and the common person. If we find this question, why we and the universe came to existence, this will be the ultimate victory of human intelligence. One day this knowledge will be for everyone, not just for scientists but for every normal person. And then perhaps we will be able to find the greatest secrets of our existence. So much for today. We will then find you with a new topic in a new episode.